All right, in this lesson, we are going to work on solving systems of equations using matrices. So in this lesson, we're going to work on writing a system of equations as an augmented matrix, then understanding what row-echelon form is, and then converting our augmented matrix into row-echelon form. And in order to do that, we need to know the rules and tricks in order to be able to change the items in our matrix. After we have our matrix in row-echelon form, we can use it to solve for variables and then check the solutions. So first of all, how do I write a system of equations as an augmented matrix? So first of all here, let's look at this system of equations. So we have two equations and we're trying to figure out when they're going to have the same x and the same y, or if we graphed them, that's the same as saying when they're graphed, when are they going to overlap each other. So in order to write this as a matrix, we have to make sure that our variables or our terms all line up, so terms are lined up. So we have our x's first and our y's second, so that works, and then our constants are over here. All right, so we can write this matrix. We'll set it up, and what we do is we use the coefficients that go with each term. So this is going to be a 2 for our x, a 3 for our y, and our 6 is the constant. And then in the other row we have, there's nothing in front of the x and the y, so we know that they are 1s. So that's going to be a 1, and then the y is going to be a -1, and this is 1/2. So this is an augmented matrix because we have our coefficients on one side and then a line, and then our constants on the other side. So what is row-echelon form? So row-echelon form is a matrix where we have 1s in the diagonals and everything underneath the diagonals is a 0. So and when we set it up, we want to get the diagonals to be 1s, everything underneath the 1s to be 0s, and these over here just stand for whatever number they end up happening to be after we manipulate the matrix in order to get the 1s on the diagonal and the 0. So these other ones to the top of the diagonal can be anything really. The only thing we're worried about getting is 1s on the diagonal and 0s under. And once it's in this form with 1s on the diagonal and 0s underneath, then it's in row-echelon form. If we had 3 terms and 3 equations, then it might look like this: 1, 2, 3, a 0, and a 0. And then up here would be other terms. All right, so this would be in in row-echelon form because we have 1s on the diagonal and 0s underneath it. So our goals for this lesson are to be able to change our augmented matrix into row-echelon form. And then once it's in row-echelon form, we can use it to solve for the variables. So remember, these all stand for coefficients that go with the variables for our terms. So in this one, this means that the first 2 terms are equal to 0. So we only have one variable, and it will be equal to something. So this lets us know what the value for one of our variables is. Once we know this one, we would plug it into this row to figure out the other variable. And then once we know this one, we can plug both of the variables we know into the first row in order to solve for the third variable. All right, so main concepts to understand right now are that when you have a system of equations, the first step is to write it as an augmented matrix. And the next thing we are going to do is work on trying to turn it into row-echelon form. So we're going to try to change our matrix so that we have 1s on the diagonals and 0s underneath them. So how do we change the coefficients that are in the rows? So we have a few options for changing the items in our matrix. We could switch the rows around. We can add or subtract one row to another row. We can multiply the row that we want to change by a factor. And we could use a combination of multiplying a row by a factor and then adding or subtracting it to another row. So let's try this. All right, here we have the system of equations. Our x's are lined up, our y's are lined up, and our constants are lined up. So we can go ahead and write our augmented matrix. We have a 2, a 3, and a 6, a 1, a -1, and a 1/2. Right? Augmented matrix, because we have our coefficients on one side and the constants on the other side, separated by a line. Our goal is to try to get this into the form we have a 1 and a 1 and a 0. So let's look at this. The first thing we want to look at is our top left corner. So we want this to be a 1, and it's not. So our choices are, we can try to add another row, we can multiply, we can also switch rows. And you may notice that here, this is a 1. So if we switch these two rows, then we'll have a 1 in the correct place. So that'll be our first step here. And we'll write that as, well, this is row 1 and this is row 2. So what we're going to do in order to get the 1 in the top left corner is we're going to switch row 1 with row 2. All right, now we have 1, -1 and 1/2, and we have 2, 3, and 6. All right, so now we can see here that we have a 1 in the right spot. Now let's look at this. So now we have a 2 down here. And what do we want that to be? Well, when it's in row echelon form, that will have a 0 underneath it. The 1 will have a 0 underneath it. So this here would be a 0. How can we turn that into a 0? Well, if we multiply the first row, so row 1 times -2, and then we add that to row 2, then that would be letting us add a -2 to the 2, and it would turn that into a 0 there. So what we're going to do is we're going to multiply row 1 times -2, and then add that to row 2. All right, so 1 times -2 is -2. -1 times -2 is +2. And 1/2 times -2 is going to be -1. So our new matrix now is going to have a 1, a -1, and a 1/2. That top row stayed the same. But now our bottom row, -2 plus 2 is 0, 3 plus 2 is 5, and 6 take away 1 is 5. Right, we can see we have a 1 and a 0. So remember, these all have to be 1s on the diagonal, so the only thing we have left now is to try to turn this 5 into a 1. And you might think like, oh, well, maybe I'll try to add a -4 to that to get it to a 1. But if we try adding things, that'll change this first value on us, and we want that to stay a 0. So what we could do is we could multiply row 2 times 1/5. Because if I multiply 5 times 1/5, that'll give me a 1 there. So row 2 times 1/5 will give us our new row 2. All right, so our first row is staying the same. Let's copy that in. And then 0 times 1/5 is 0. 5 times 1/5, that's going to be 1. And 5 times 1/5, that's going to be 1. All right, so now we have 0s on our diagonals, 1s on our diagonal, and a 0 underneath. So now this is in row echelon form, and we can use it to solve for our variables. So remember, 0 and the 1, this stands for 0x plus 1y equals 1. Because that's a 0 there, this goes away, and now we know that y equals 1. Now we can use that and plug it into our first row in order to figure out what x is. So we have 1x minus 1y, but we know that y is 1, equals 1/2. So x minus 1 equals 1/2. So x equals 1 plus a half is 1.5 or 1.5. All right, so our solution to this set of equations is x is 1.5 and y is 1, or it's 1.51. And let's plug them in just to make sure it works. So if we plug these in, then we should get, if it's the right answer, we should get a true equation for this and a true statement for this one too. So the first one, 2 times 1.5 plus 3 times 1 should give us 6. So 3 plus 3 should give us 6, and 6 equals 6. So this one works. All right, for the next one, we have 1.5 minus 1 is 1/2 or 0.5. 1.5 take away 1 is 0.5, so we get 0.5 equals 0.5, and that's true. All right, so let's take a quick peek at what we did here again. So first step was write it as an augmented matrix. Then we had the goal of trying to get ones on the diagonal and zeros underneath, or putting it into row echelon form. We wanted to get a 1 in this top left corner, and we realized if we just switched these two rows, we'd have a 1 in that corner. Then we worked on trying to turn this 2 down here into a 0, and in order to do that, we multiplied row 1 times -2 and added it. That way we're adding a -2 to this. So -2 times row 1 plus row 2 gives us our new row 2. Now we had a 1 here and a 0 here, and we needed to try to make this 5 into a 1. We did that by multiplying row 2 by 1/5. And when we did that, now we had a 0 here and a 1 here, and now it's in row echelon form. After it was in row echelon form, we started with the bottom row to try to start solving for the variables. Y equals 1. And then we plug in y is 1 into the first row in order to solve for x. Once we knew the solution, we plugged it back in to check our work. All right, so let's solve this system of equations using matrix. So this one's a little different. We can see that we have 3 terms on the left side of each equation, and we also have 3 equations. So this matrix is going to look a little different. So remember, the first step is to set up an augmented matrix. So first, let's make sure our coefficients all align, and they do. X's are all lined up, our Y's are lined up, and our Z's are lined up, and our constants are lined up. So the coefficients, again, remember, if they're not there, if there's nothing in front of it, it's just a 1. So we have 1x, 1y, and 1z equals 3. 1x, 2y, 3z is 0. 1x, 3y, and 4z is -2. All right, and remember, our goal is to try to get it into row echelon form. So what is that going to look like for this matrix? So we're going to have 1s on all the diagonals, 0s underneath those 1s, and then these last ones here. Maybe I should push this one over a little bit. All right, so our goal is to just get 1s on the diagonals and 0s underneath those 1s. All right, so let's see what's happening here. Well, we have a 1 already there, so this one's all set already for us. All right, so let's look at the next one. We want this to be a 0 now. How can we change that into a 0? Well, we could do row 2, take away row 1 for our new row 2. All right, so we're going to do, let me get a different color here. So we'll do row 2, take away row 1. So this is going to be -1, -1, -1, and -3. And that new matrix now is going to look like 1, 1, 1, 3. The top doesn't change, but our next row is going to be 1 plus -1 is 0, 2 plus -1 is 1, 3 plus -1 is 2, and then 0 plus -3 is -3. And then our bottom row is going to stay the same. So that's 1, 3, 4, and -2. All right. And when we did that, it worked out for us. This one we fixed in the last one. We just changed this one to a 0. And look at this one ended up being a 1 for us. And that was perfect because that's one of our diagonals. So that worked out nicely. So the next thing we need to work on is we can look at this one. We want this to become a 0. How can we do that? Well, we could do row 3, take away row 1 will be our new row 3. So 1 take away 1, 3 take away 1, 4 take away 1, and -2 take away 3. So our bottom row now is going to be 1 plus -1 is 0, 3 plus -1 is 2, and 4 plus -1 is 3. And -2 plus -3 is -5. And our other two rows did not change. So this is still 1, 1, 1, 3, and 0, 1, 2, and -3. All right, let's see how we're doing here. We have a 1 and a 1, a 0 and a 0. So the next thing we can work on is this. Let's try to get that to be a 0. So if we thought about, if we think about trying to get one of the other rows to be a -2, like multiply one of the other rows by -2 and adding it to 2, that would work for us. But we just have to be careful because we want to make sure we're not accidentally changing this 0 into something else. So if we look at row 1, if we decided to do this with row 1, if we say, well, we're going to do row 1 times -2 and then add that to row 3, look what would happen. 0, so we did 1 times -2 would be -2, and then we add that, that would change that 0 to -2. So we don't want to choose row 1 to do this with. We can do it with row 2 though, because there's a 0 here. So when we multiply that by -2, it's just going to be 0. So we're going to multiply row 2 by -2 and then add it to row 3 for our new row 3. All right, so 1 times -2, I'm sorry, we're doing second row. 0 times -2 is 0. 1 times -2 is -2. 2 times -2 is -4. And -3 times -2 is a +6. So now our bottom row, 0 plus 0 is 0. 2 plus -2 is 0. 3 plus -4 is -1. And -5 plus 6 is +1. And the top two rows did not change. So this is still 1, 1, 1, 3, and 0, 1, 2, -3. All right, looking good. We got this, 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 this. All right, we're almost there with this one. This needs to be a 1. And if we multiply row 3 by -1, that will change everybody's sign, and that'll turn that into a +1 for us. So we'll do all of these times -1. Okay, the new matrix will be in the bottom row, that will be a 0, a 0, -1 times -1 is +1, and -1 times 1 is -1. So it changed that one over there to a -1 now. And our other ones are the same still. All right. Yay, it's in row echelon form. Okay, we have our 1s on the diagonal and our 0s underneath. So now we can start with that bottom row to start solving for variables. So remember, this is x, this is y, and this is z. So in the bottom row, we have 1z, or z equals -1. And if we plug now that z into the second row, then that 1 here, that stands for a y. So we have y plus 2z, but we know z is -1, equals -3. Y take away 2 is -3. So y is going to be -3 plus 2 is -1. So we have z is -1, y is -1. And now last we can plug the z and the y into that first row to figure out x. So we have x plus -1 plus -1 equals 3. So we have x minus 2 equals 3, or x equals 5. All right, so here are the solutions and the equations. Let's plug them in to check our work. So for the first one here, x plus y plus z equals 3. Well, 5 plus -1 plus -1 equals 3. Let's see if that works. 5 plus -2 equals 3. 3 equals 3. That worked. So that one works. Let's try the next one. We have x, which is 5, plus 2 times y, plus 3 times z equals 0. So we have 5 minus 2 minus 3 equals 0. 5 minus 5 equals 0. 0 equals 0. All right, that one worked. And the last one, we have x. So we have 5 plus 3 times -1 plus 4 times -1 equals -2. Oops. 5 minus 3 minus 4 equals -2. 5, 4 negatives and 3 negatives is 7 negatives. All right, we have -2 equals -2. Awesome. All right, so let's go back to our first slide here. So solving systems of equations using matrices. So the first thing we need to do when we're doing this is we need to rewrite the system of equations as an augmented matrix. And remember, that's a matrix that has a line dividing the variables side of the equation from the constant side of the equation. Then we have to put it into row echelon form. So we need to try to get it into the form where we have 1s on the diagonals and 0 underneath those 1s. We talked about the rules for converting an augmented matrix into row echelon form. So we could switch the rows. We can add or subtract the rows. We can multiply a row by a factor. We can also use a combination of multiplying a row and then adding that product to the other row. So a combination of multiplying and adding. Then once we have it in row echelon form, we can start by solving that bottom row for the variable that's in there. Once we know that variable, we could solve for the second row or whatever the next row up. And we keep doing that until we have solved for all of the variables. And then finally, once you have the variables, you can plug them back into your original equations to make sure that they are solutions, to make sure there weren't any mistakes there.